on your formula sheet, there's cosexes and cos 2x's and sine 2x's. They're called the double angle identities because they have a 2 besides the angle, aka double angle identity. So sine, if you see sine 2a, you only have one option. But if you see cos 2a, you have 3. So the cos ones are a little bit harder, but they're not actually, because the rest of the stuff gives you hints as to what you should pick from the coses. So we're going to start with b first. Sure. We'll start with b first. So if you see a sine 2x or a cos 2x and I ask you to solve, you immediately have to go to your formula sheet and replace them with something. You cannot solve a cos 2x. You cannot solve a sine 2x. You have to immediately go to your formula sheet and replace them with something you can solve with. Okay? So when you see a cos squared, you might be able to solve with that. If you see a sine squared, you might be able to solve with that. But if you see a cos 2x, like a double angle, or a sine 2x, they have to get replaced. Cool thing about sine 2x is there is only one option. Now some people are like, when do I leave brackets? When do I need brackets? When don't I? If this said 2 sine 2x, it's just a side note, don't write this, just if it said this, I would be replacing the sine 2x, so I would get 2 times 2 sine x cos x. So I would need brackets because this 2 would have to multiply in. Do you see that? If instead of a 2, if I had had a negative 1, let's say it was a negative 1 sine 2x. Well, now I would have a negative 1, and then I would have to put that still in. So if there's something in front of what you are inserting, you have to have brackets. But if there isn't, you can just insert it. So is there anything in front of this sine 2x? Is there anything in front of it? Is there a coefficient? No. So we're going to go to sine 2x. Sine 2x is 2 sine x cos x. Do you see that? We're going to rip the sine 2x off the page. We're going to throw it away. We're going to pull this 2 sine x cos x off our formula sheet. And we're going to put it in its place because it's equal to it. Okay? So take the sine 2x, toss it off, and replace it with 2 sine x cos x. Because on the formula sheet, they're the same thing. Then the rest stays the same. Minus cos x equals 0. Now, I'm going to tell you this over and over and over and over again. If you're stuck in a solving, if it's like a squared, most people can do it. They know they need to factor it. They factor it. They're great. If you're stuck on a solving, 99.999% of the time, you're stuck on a solving because you're missing a GCF. You're missing that you can take something out of it. So you sit there and you stare and you say, I don't know what to do. Well, what we can do if there's sines and coses, we can use 2 variables. We can go let m equal sine x, and we can say let n equal cos x, and we would get 2mn minus n equals 0. If I asked you to solve, or I asked you to factor that in grade 10, what could you do? Remember, if you're stuck and there's nothing you can do 99.9% of the time, it's a GCF. What could you do? Take out an n. Take an n out. Up here I could take a cos x out, right? Here I'm taking an n out. When I take an n out, what's left? 2m minus 1. Now I still have 2 factors. I have n equals 0, and I have 2m minus 1 equals 0. So n equals 1/2, because I'm adding the 1 and dividing by 2. N isn't actually n is cos x. So I have cos x equals 0, and I have sine x equals 1/2, which you should be excited about, because both of those are on the unit circle. What is my domain for this? That's what I have to look at. 0 to 360, is it inclusive of 360? No. If I did it in integral notation, it would be 0 degrees, comma 360, with a round bracket. So 0 I would put as a solution, but if 360 is an answer, I don't state it. So where is cos x equal to 0? Where is cos x equal to 0? 90 and 270. And those both fit in 0 to 360, right? What about sine x equals a half? Where does that happen at? $30 and where's the other one? $150. Do I have to look for coterminal ones? No, my restricted domain is the unit circle, right? Is the basic unit circle, 0 to 360. So I don't have to look for anything bigger or anything smaller because 0 to 360 is the unit circle. Am I done now? Or do I have to actually do something at the end to prove what solving it is? No?
You have to do something at the end to prove what solving is.
What do you have to do?
Have to write
Variable? What's the variable? Go back to the top. What's the variable? An x. X equals what? 90, 270. What else? 30 and 150, and then box it. I usually write them in order, but it doesn't matter. I don't think it's the pencil. Okay, why is A a little harder? Yeah. Cos 2x, no, doesn't have a coefficient. Why is it harder? Yeah.
because cos double angle has 3 options.
Yeah, we have 3 options, not just one, right? Sine 2x is 2 sine x cos x. We have no options. Cos 2x has 3 options. Now, you don't willy-nilly just pick the 3 options. The 3 options are actually like educated guesses here, okay? So we have, let's look at what the rest, when you want to decide what you have, you look at what the rest has. So if I got rid of the cos 2x, I have a 1 minus cos x. Do you see that? That's what the remnants are that's left, 1 minus cos x. So I need to pick something that'll go nice with 1 minus cos x, okay? If I pick cos squared x minus sine squared x, then I'm going to have cos squared x minus sine squared x plus 1 minus cos x. Now I have sine squareds and cos squareds mixed. Is that helpful? No. Okay, if I look at the bottom one, it's 1 minus 2 sine squared x. So now I have 1 minus 2 sine squared x minus 1 plus cos x. Now I have sine squareds and coses still mixed. Is that helpful? No. The middle one is 2 cos squared x minus 1. Mixed with a 1 and a cos x. That's pretty good. I have a cos squared, I have coses, I have numbers, I don't have things mixed, right? So I'm going to pick the middle one because it goes best with what the heck's left here. If instead of this being a cos x, this was a sine x, I would pick the third one. The third one that had the sine squared x, right? So you pick by what else is in the equation once you actually get rid of what you have. So I'm going to pick that second one, which is 1 minus, no, it's 2 cos squared x minus 1. So this here, I'm going to rip off my page, and I'm going to replace it with 2 cos squared x minus 1. And then the rest all stays the same. Plus 1 minus cos x equals 0. Didn't need to do that. So the minus 1 and plus 1 just happen to cancel in this one. And I'm left with 2 cos squared x minus cos x equals 0. My rule, if I have a squared, is everything needs to be to one side equal to 0, right? Can I factor this? It doesn't have a third term, so I can't just like actually product sum or decomp it. If the coses are overwhelming, what did I tell you to do? Yeah, replace them with an m. So let m equal cos x. So replace them with an m. You don't have math 2 times in a row. It's a sour one. It'll keep you awake.
No.
All right. So we get 2m squared minus m. And I told you, if you get stuck, if you're stuck and you don't know what to do next, 99.9% of the time, what should you do next? Yeah.
99.9% of them are probably missing GCF.
Probably missing a GCF. So what can we take out? Noah.
An M.
An m. And we're left with 2m minus 1.
How much that 15 minutes?
All that 15 minute of review, just so much material. You should have your mom watch this podcast at 10:49 to show that we are promoting your 15 minutes of review a night. Right, Mrs. Z? Yeah. Yeah. So m equals a half. And m is cos. Cos x equals 0. Cos x equals a half. You give me the answer between 0 and 3.
Rumor has it the same. I won't get one right.
Cos x equals 0 here and here. That is true, 90 and 270. But cos x equals a half is not where sin x equals a half. Cos x equals a half here and here. Cos is x. Cos x equals a half at 60 and 300. So we go back, we look at what variable it is, because we don't want to put theta, because this is not theta. What is my variable? X. So in the end, I want to say x equals 60, 90, 270, 300. And I know some people say, but Mrs. Lepp, if I just put theta, they'll know. No, they won't, because think about it mathematically. If you're saying solve for what the variable is, and you say theta equals 60, 90, 270, and 300, and I'm like, there's not even a theta on this question. That's great that theta equals that, but there's no theta to even equal, right? So mathematically, it is kind of silly, like it doesn't make sense that you put theta when the variable's x. So always go back and make sure you're actually saying what variable was in the question equals the answers, right? Because that mathematically makes more sense than you just writing a random variable equals something and there's no random variable in the question. All right, we're going to flip over. So, we're going to do B first. But what I want to bring back to you is rationals from grade 11. So, in every other grade previous, you had like 1 over 12. And you had no non-permissible values and no restrictions because my denominator couldn't be 0 because my denominator is 12, right? Or you were given 3/4. And I was like, what's the non-permissible values? You'd be like, I have no idea what you're talking about that. Non-permissible values happen when the denominator equals what? What can't your denominator equal in a fraction? 0. If your denominator equals 0 at any point in time, the question is done. The question doesn't work, you cannot use it. Okay? So, if at any point in time your denominator equals 0, you got problems. So that's why we state non-permissible values whenever you have a variable in your denominator. Because the moment you have a variable in your denominator, you have a chance of that denominator being 0 if a variable is a specific number. So in grade 11, we talked about something like this. We had like 1 over x plus 1 plus 3 over x minus 3, let's say. The moment we have a variable in our denominator, we have to state restrictions. We have to state non-permissible values, values that are not allowed, that are not permissible. That's why it's called a non-permissible value. They're not permissible. Because if you use them, you get a 0 in your denominator, and we're not allowed to have a 0 in our denominator, right? So the moment you have a variable in your denominator, you have some restrictions. You have some values that are not permissible. So what would my value be here that would be not permissible, that would turn that whole denominator to 0? Okay? Right. So in grade 11, we'd say x can't equal -1. Because if it did, I'd be done at this step. This step, I wouldn't be able to add these. I wouldn't be able to do anything. I'd be done. Because if I have a -1 as my x, this becomes 0, the whole question is done. The moment your denominator is 0, you're done. So if we don't want ourselves to be done, we have to state non-permissible values. So that's a non-permissible value for this part of the fraction. But what about this one? What would cause me issues for that side? See? Yeah. X can't equal 3. So for this particular rational in grade 11, we had two non-permissible values, two values that couldn't happen. And if they did happen, our denominator would be 0. Whole question is done. Okay? So now we hit trig. Trig functions have variables. If a trig function doesn't have a variable, you don't have a trig function, you have a weird word, like cos, or tan, or sin, right? If you don't have a variable beside those, you have literally a word that is useless in mathematics. So every single trig ratio is followed by a variable like theta or x or m or whatever, but every trig ratio has to have a variable sitting beside it because that's your placeholder for your angle, right? So if you ever have a trig ratio in a denominator, you have non-permissible values. You have values that would create that denominator to be 0. So if we look at b here, I see that I can switch tan to sine over cos. So let's try that. So here I have sine squared x equals 1/2. Tan I can switch to sine x over cos x. And the reason why I know I should do that is because the cos x's will cancel. Anyone who had me in 20-1 knows that before I cancel anything off in rationals unit, what did I tell you to do? I told you to slap your hand and say state non-permissible values, right? The moment you have a variable in your denominator, you have options that will completely take this equation and throw it out because the denominator will become 0, and then the equation's done. You have to state NPVs the moment you get a variable. Look at, I have an x in the denominator. It happens to be stuck to a cos, but I have an x in the denominator, right? The moment you have a variable in your denominator, it doesn't matter if it's trig ratio, you have non-permissible values, or you possibly have non-permissible values. We've taught that, like, if we have an addition of squares, you can't have non-permissible values. So there are cases that when you get a variable in the denominator, they don't create problems, but 99% of the time they do. So what am I looking for? I'm looking for all the places where cos x equals 0. I'm looking for all the angles that would create cos x to be 0. Because if this turns to a 0, which I'm going to take off in a second, if this turns to a 0, the question's done, right? Do you get what I'm saying? So I have to find all the places where cos x equals 0 and then say those x's can't happen. And the cool thing is I don't have to do general form. I can just do it between 0 and 360 because those are my only, that's where I'm finding my answers, is between 0 and 360 for this question, right? So I need to find all the places where cos x equals 0. Where does cos x equal 0? 90 and 270. True? So x equals 90 and x equals 270. So just like this was way easier to see, this was way easier to see. I understand this is way easier to see. If I plug a -1 in, this becomes 0, right? If I plug a 3 in, this becomes 0. That's way more obvious to see where the zeros will come from, right? Same thing happens here. If I plug a 90 in, if I plug 90 degrees in, what's cos of 90 degrees? 0. Then my denominator is 0 and I'm in trouble, right? If I plug in cos 270, what happens to this denominator? It becomes 0 and I'm in trouble, right? So between 0 and 360, my troubles are going to happen at 90 and 270. Because if I plug a 90 and a 270 in, this question's done right there. Because those denominators will be 0. Because cos of 90 is 0, cos of 270 is 0. Could I plug in cos of 30? Cos of 30 through 3 over 2. Is that a problem? No, my denominator is not 0. Could I plug in cos 210? Cos 210 is negative root 3 over 2. Is that fine in the denominator? Yes. There's two places that will cause that denominator to be 0 between 0 and 360, and that's at 90 and 270. Because cos of 90 is 0. Cos of 270 is 0. So I have to, right over here, say x cannot equal, I state my non-permissible values, x cannot equal 90 degrees and 270 degrees. Because if it equals 90 and 270, that denominator would be 0 and I'd be in trouble. Now some people will say, but the denominator, the cos x's are going to cancel off right now. The problem's going to be gone. Doesn't matter if the problem goes away. In this step, those two numbers are a problem. In this step, if I plug them in, I'd be done. So it doesn't matter that the second step, the problems cancel off and they're gone. If at any point in time you have a problem through the whole thing. Because if I put in 90 or 270 right here, this step is done. I can't do step 2, 3, 4, 5, 6, whatever there is. So I state my non-permissible values, and then I can cancel. You always state your restrictions or the permissible values that are not allowed before you cancel. Because if they were a problem at any point in time, they're a problem throughout the whole question. Okay, so we stated them, we can move on. Now this cancels off and this cancels off, and I'm left with sine squared x equals 1/2 sine x. So much grade 11 and 10 comes into everything we do. Restrictions only make sense because we used them last year with rationals, right? Then it kind of makes sense with trig because you understand why you can't have a 0 in your denominator. It's the first time you've ever had variables in your denominator was last year. Last year we also dealt with squares. The moment I have a squared, what do I have to do? Put everything to one side and get it equal to 0. That has to be embedded in your brain. That has to be just a second nature thing. Like when you hear y-intercept, you hear x equals 0. When you hear x-intercept, you think y equals 0. When you see a squared, you think move everything to one side, set equal to 0. That has to be part of your being. It has to be just what you do. You see a squared, everything to one side, set equal to 0, or you're not solving. Because you'll get stuck on the grade 11. Now people don't see that as a grade 11 problem. That is a grade 11 problem. If you don't know to move this over and set it equal to 0, you're missing the grade 11 math. You're not missing grade 12. Grade 12 is the sign stuff. If you can't move that over and set it equal to 0, it's the grade 11 stuff you're getting stumped on. Right? That's grade 11 skills. So how do we move 1/2? This is a positive 1/2 sine x. I move it over by subtracting it. There's not division. Some people want to divide. We're not dividing. We're moving that whole thing over so that it equals 0. If you divide by anything, it doesn't equal 0. If you divide sine x by sine x, it's a 1 left over. Right? I want nothing left over here. I want it all to go over. How do I move the complete thing over? By adding or subtracting it. If you divide sine x by sine x, you have a 1 left. I don't want a 1 on that side. I want a 0. So I'm taking this whole term and I'm saying I need to take this whole thing, I need to move it. How do you move a whole thing and get something equal to 0? By adding or subtracting, not division. So we move it over and we get sine squared x minus 1/2 sine x equals 0. Now, if the sine x's are overwhelming, get rid of them. Replace them with an m. So let m equal sine x. So I get m squared minus 1/2 m equals 0. And a lot of people get stuck here. Remember, when you're solving, 99.9% of the time, when you're solving, if you're stuck, it is what? A GCF. What can I take out? An m. That's it. I can take an m out, right? Don't let that half overwhelm you. Just take out an m. So I take an m out, and I'm left with m minus 1/2 equals 0, right? Nothing crazy. Just take it out of GCF. Just fractions make you guys twitch a little. But trust me, don't let it throw you off. It's just a GCF. And so I get m equals 0, and m minus 1/2 equals 0. M equals 1/2. Ooh, I went to go box it. That would have been bad. M isn't even a variable. What is M? Yeah, sine x equals 0, and sine x equals 1/2. Now we go back here and look at my domain. Okay, my domain is in degrees. 0 is included. If I get the answer 360, am I allowed to keep it? No, not included. You see, it's just less than 360, not equal to it. Okay, where does sine x equal 0? 0, 180, and 360. What's the catch? No 360. Because my domain didn't include it. You have to watch those endpoints. Those restricted domains, you have to watch the endpoints. Is it inclusive or not? Is there an equal sign or not? And then sine x equals 1/2 when y equals 1/2, which is here and here, which is 30 and 150. Then I say theta equals 30, 150, 0, and 180. Is that what I say? What's the variable? Go back to the original question. The original typed question. What's the variable sitting in it? X. So I'm going to say x equals 0, 30, 150, 80, 180. I like writing them in order. You do not have to write them in order. It's a thing I enjoy. Okay? Does that make sense? Does the non-permissible values make sense? We actually do a lesson on non-permissible values, but this makes more sense. Now you have to watch yourself with your non-permissible values. You actually, every single time you solve, you have to check and make sure your answer is not a non-permissible value. What were my non-permissible values? X can't equal 90 or 270. Did any of these equal 90 or 270? No, they're good. If they did, they'd be extraneous. Your homework is on Google Classroom, but I'll post it here too. It's under Chapter 6 homework.
So we have to include that last part in the development.
Sorry?
We have to include that.